I live in Saudi Arabia studying 10th grade in Yambo International School. So what's so special about this section? Well, in this section, following this is one we'll be studying probability and study of probability, counting possibility, insertion of mathematics, very important. But in this section we'll also be talking about counting principles. Now let's say if you flip a coin, you say it's a flip a coin, and also then roll a 6-sided die. What's the probability of it? Well, we can write this as H1, heads 1, heads 2, heads 3, heads 4, heads 5, heads 6, and then tail 1, tail 2, tail 3, tail 4, tail 5, and tail 6. This is all the possible outcomes that you can get. Okay. Now, since since there was just die and then the coin, we can simply go ahead and write this out. But what if it was something big, which has many sides, like octagon and so on, dodecagon sided die? Okay, whatever you're going to do that. Well, a coin has 2 sides, so let's put down 2. You multiply that by the side 6-sided, so 6, which gives you 12, which gives you 12 possible outcome. So let's go ahead and count it down. Okay, with blue marker. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Perfect. So you know how this works over here. Okay, now what if someone were to ask you, and this is all a game of probability, and I'm sure you have played this game at your house. Okay, what if someone were to ask you that how many 2-letter words are possible? Okay, so without replacement, basically means that it's 2-letter words, right? So you can have 26 words times 25, which gives out 650. Now, in our English alphabet, there's 26 words, okay? Now I'm telling you how did we get 25 here. So we have 26 words, and since we used one word, we can't replace it with another one. So if you were to take out of A to Z, okay, you took Z or some kind of letter out. Now you have only A to Y or something. Okay, so now you only have 25 letters. So you can add Z at the back. So it's 25. So 26 times 25 yields 650. Now what if you were to have replacement? Which basically means you can put the Z back in. So once you used one letter, you can put that back in. It's like card of deck. Once you flip the card, okay, when you saw the card, you can put that card back. Okay, and without replacement means once you pick the card, you have to take the card right away. You can't put it back down. Okay, so we have 26 cards times, you can replace it, so it will be 26 times 26 or 26 squared, which gives us 676. So you see, there's so many letters possible. Now, this involves a topic called permutation and combination that we break down by going through this section over here. Now let's say you were to have 8 books. Permutation and combination plays a major role in study of probability. So let's say you draw 8 books over here. So if we have 8, 3, 4, 5, 6, 7, 8, 8 books right here. Okay? What is the probability that you have a stack. Okay, you have a stack right here that you can fit three big books. 1, 2, and 3 big books over here. What is the probability? Well, the probability is that you have 8 books. 8 times 7 times 6, okay, would basically, if you take the last 3 out, multiply them together, you have 336, which is the probability. Now, permutation is where order is important, okay? We'll talk as you move on. I will show you something else where order is not important, but since we are talking about permutations, okay, let me go ahead and write it down. Erase this example over here. Now, what we are talking about is the idea of permutations, which basically means order is important. Now, what we'll do is basically go ahead and solve some equations related to permutations, but before we actually go on to that, I'll give you guys a formula of permutation on how basically it looks like. Okay, so the first one, I'll teach you guys on how it's arranged and how it's being used. So permutation is where order is important. Okay, remember that. So the formula, when we come up to the formula, if we take 8 items for 3 books, okay, same with our block story with 8 books, okay, and so on. So if we had 8 books and we can only stack 3 at a time, how many possibilities do we have on arranging the books? First book, second book, and third book out of 8 books. So 8 books taken 3 at a time. How many probability do we have? Well, you don't have to always count the way we did before, which is 8 times 7 times 6, okay? What you can do is use the permutation formula, which basically says the highest number over here, which is 8 over here. Then basically what you do is 8 minus 3 factorial, okay? Basically this would yields out 8 times 7 times 6 times 5 factorial. Let's stop right there because 8 minus 3 would give out 5 factorial as well. So what you need to do now is cancel this with this, okay? Basically it yields out what we had before, which is 8 times 7 times 6, which basically gives us 336. Now again, most of the people say that this permutations make sense to them better than the actual probability. So the only thing careful about this is that it tells you in the question that order is important or gives you some kind of hint that order is important. Then only you can use the formula of permutations. So let's move on to our next example of permutations. Okay, so the first question tells us, in how many ways can a letter A, B, C, D, which is 4 letters, can be arranged? Okay, so basically it doesn't 4 letters, which is A, B, C, D. How many ways can we arrange this 4 letters? Where since there are 4 letters, we can have 4 times 3 times 2 times 1, or basically you can just say 4 factorial, okay? So doing this, we would find out that there's 24 possible ways in which we can arrange this 4 letters over here. Okay, now let's move on to our second example using the idea of permutations where order is important. Now the second question tells us how many 3-digit numbers area codes are possible in the first digit, and the first digit cannot be 0. So it's giving you a condition that the first digit cannot be 0, other digits can. So total, let's see, there's 3-digit code in some area, okay, and the first digit cannot be 0. Okay, so out of 1 to 10 numbers, we can have 9 numbers for the first one, because the last one, which is 0, is not, we cannot use that. The second one we can, so it's 10 digits. The third one would be 10 digits as well, right? So what we need to do, 9 times 10 times 10, which basically yields out 900. So we can make 900 codes of 3 digits, which does not include 0 as their first digit. Okay, now let's go on and talk about the permutations of books that we just talked about a moment ago. 8 stacks of books taken. So that's it for permutations. Thanks for watching.